In part two of our probability discussion, we want to talk about compound events. Now, compound events are when you take two or more events together. And there are two different kinds that we talk about. We talk about mutually exclusive events, and we talk about overlapping events. Mutually exclusive things are things that can't happen at the same time. So two events that can't happen together are mutually exclusive events. An example would be if we were to spin a purple and a yellow at the same time on the spinner shown. Well, we couldn't do that. Our spinner can't be on both purple and yellow. Now, it might be on the little line here, but it can't be on both of them. That can't happen together. So the probability of two mutually exclusive events happening is the probability of the first one happening plus the probability of the second one happening. So in our case, we would take the probability of purple or yellow, the probability that it will land on either purple or yellow, is equal to the probability of purple. Now, what's the probability that our spinner will land on purple? Well, it's 2 out of a total of 8. 2 out of 8. And that's our probability of getting purple, plus the probability of our getting a yellow. So the same probability for yellow is 2 out of 8. So that's our probability of getting both of them. And then we add those together. So our probability is 4 out of 8, or we can say that that is what? Well, it's 1/2. We have 1/2 probability, or 50% probability of getting purple or yellow. And when we look at it, that makes perfect sense because that's 50% of what's going on there. Next kind of event we want to talk about are overlapping events. Now, overlapping events can occur together. An example would be spinning an odd and a purple at the same time. So if we look at our odd numbers, we have 1, 3, 5, and 7. Now, our purple numbers would be 8 and 1. So if we were to get both of those together, we would actually do this one twice. We could get those at the same time. So we could have purple and odd at the same time. Those are overlapping events. So let's look at how to calculate that probability. The probability of getting odd or purple, right? So odd or purple, A or B, is equal to the probability of getting A plus the probability of getting B, our second event, minus the probability of getting both of them together. So the probability of getting odd or purple is the probability of getting odd, which we know, as we said before, was 1, 2, 3, 4. We know that's 4 out of 8. Plus the probability of getting purple, right? So we saw that that was 2 out of 4. There's two ways to get that, plus 2 out of 8, rather, not 4. And then we're going to subtract the ways that we can get both odd and purple. Well, there's only one way in our example to get odd and purple, and that's to get the 1 because it's both odd and a purple. So we're going to subtract 1/8 from that. So 4 plus 2 is 6/8, minus 1 is 5/8. So our probability of getting odd and purple is 5/8. Now we've been finding the probability of one thing or the other, which means that we include the probabilities, we add them together. Let's look at finding the probability of something and something else. We're trying to find the probability of one thing happening and another. We're trying to find the probability of them both happening at the same time or together. Whereas with or, we were finding the probability that one or the other could happen. So in this case, we're talking about independent events first. The probability of one event doesn't affect the other when we're talking about independent events. Here's an example. Let's say the probability of rolling a 3 on a 6-sided die. Well, we know that's 1 out of 6. And the probability of spinning a blue is 3 out of 8. Now here's the deal. Nothing about rolling this die is going to change the result of what I get on the spinner. And nothing about spinning the spinner will change the result of the die. They're not connected. Those are independent events. And to find the probability of independent events, we don't add, we multiply. So if we wanted to find the probability of getting a 6 and a blue, we would find that that's 1 out of 6 is the probability of getting a 6. And the probability of getting blue was 3/8, and we would multiply those together, and that would give us 3/48. Or we could simplify it, and 3 will go into 3 one time, and 3 will go into 48 16 times. So 1/16 is our probability. But remember, we have to multiply them together. Now remember probability using and, we're usually going to be talking about getting one thing and then getting another thing immediately afterwards. And that brings in the issue of replacement. And here's what I mean by that. Let's say I gave you this particular situation. We have a little bag here with some marbles in it. Find the probability of drawing a red marble, then putting it back in, and then drawing a green marble. So we take one of the marbles out, we find out that it's red, right? We got a red marble, and then we put that marble back in, so our number doesn't change. Let's see how we can find that probability. So to find the probability of getting red and green, or red and then a green, with replacement, we'll start with finding the probability of getting a red. Well, there are 3 red marbles, so we know that we have a chance of 3 out of a total of 6, right? There are 6 balls in there. And then we've got probability of getting a green marble. Well, the probability of getting a green marble is 1 out of 6. And remember that we are going to be multiplying those, not adding them together. So that's going to give us 3 out of 36. And then when we simplify that, we'll get 1 over 12. So if you'll notice, our probabilities of getting 2 things together actually are going to be smaller than our probability of getting one thing or another. So that's probability with replacement. We're putting the marble back in. Let's look at without replacement. Here we have our same sack of marbles. In this case, we want to find it without replacement, which means when we take our marble out, we're going to leave it out, right? Which is going to change the number of marbles in the bag. If I have a red marble and I take that red marble out, well, now there's only 5 marbles left in the bag. And that's what we mean by without replacement. We're not putting it back. So let's find that probability without replacement. So the probability of red and green without replacement. Probability of red, again, is 3 out of 6. When we reach in there that first time, we have a 3 out of 6 probability of getting it. Then what's the probability of green? Well, once we've removed that red marble, there's only 5 marbles left in the bag. So we have a probability of 1 out of 5. And again, we're going to multiply those together. It's going to give us 3 out of 30, or in this case, a 1 out of 10 chance. 1 out of 10 is our probability. Let's take a look at one last problem. It's an application problem. 1 freshman, 2 sophomores, 4 juniors, and 5 seniors received top scores in a school essay contest. To choose which 2 students will read their essays at the town fair, 2 names are chosen at random from a hat. What is the probability that a junior and then a senior are chosen? Now, is this an and or an or problem? Well, we know that one is being drawn, then another, so they're going to be drawn one after the other. That's an and probability. And is this going to be with replacement or without replacement? Well, we're choosing names from a hat. Once I draw that first name out, I'm not going to put it back in, because that would give me the possibility of getting the same person to read their essay twice. I'm going to get a different name out. So this is going to be without replacement. Let's take a look at our probabilities. We want the probability of getting a junior and a senior. So a junior and a senior, one after the other. So what's the probability of getting a junior, right? So the probability of getting a junior is 4 juniors out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 out of 12. Times, since this is and, right, the probability of getting a senior. The probability of getting a senior is 5 out of 12. And then to find our probability, we just multiply those together. 20 over 144. And then we'll need to simplify. And when we simplify, we're going to get 5/36. 5/36. And that is our probability of getting a junior and a senior to say their essay contests. I think you're ready for your homework.